Hello everyone, my name is Ahmad Nashruddin bin Abdul Talib, student ID EP0107521. For this video, my lecturer has assigned me to do a video on how I do a solution from the question in the assignment 5. So, the given function of midterm in 1, 5, 12, 13, 14, and 15. So A. Find the simplest form of function in f in SOP and BLS form using your preferred method. So the best solution to answer this question is by using the KMAT. So this is KMAT I use from the this midterm. Okay. So to find the SOP form, we need to find the value of one that is adjacent to each other. So we need to group them. As you can see here, there is four value of one is adjacent to each other, and this two value of one adjacent to each other. So the final form of SOP form is W bar Y bar Z plus W X. So to find the PLS form, we need to find the zero value that is adjacent to each other. As you can see here, zero, this four value of zero is adjacent to each other. This four value of zero adjacent each other, and these two value of zero adjacent to each other. So the final form of POS form is bracket W plus Y plus Z bracket W bar plus X bracket W plus Y bar. Moving on to the next question. Implement the simplified function f using basic logic gate. So from the SOP form given, we get from the question before, this is the logic diagram from this form. So for W bar and Y bar, we combine in AND gate, but because of this bar, we add dot gate. W bar Y bar. So to combine with Z, we add one AND gate because this time dot product. And for WX, we also combine it with AND gate. W X N. So to combine, so the plus value here it shows we need to use NOR gate. So to combine this form and this form, we get NOR gate here, and this is the whole logic diagram for this function. C is implement the simplified function f only using universal gate. So as you know, universal gate only have we learn is only have two. That is universal none and universal not. Because of the question before, we have AND gate, so it's easy we use universal none to answer this question. So from diagram before, NOT gate we change directly into NAND gate, and for both the W naught and Y naught, and here, and for AND gate here we add dot here, and to balance the output we need to add one NAND gate here. So same goes for WX here, we need to add one dot, and NOR gate we change into NAND gate. So this is the whole logic diagram in simplified of using universal NAND. Question D. Assuming all gates have a propagation delay of 1 nanosecond, identify is there any hazard in this function? If yes, what type of the hazard? So to find the hazard, we need to find the number of one that is adjacent to each other but not in the group. From the KMAT before, uh, in question 1, this value of 1 is adjacent to each other but not in group. So this is hazard can happen here because it achieve the because it's adjacent to each other but not in group, and it's called static hazard. So draw the waveform showing this hazard. So from the before we do the logic diagram, we have input W, X, Y, Z, W bar, Y bar, W bar, Y bar, W bar, Y bar, Z, and WX. So this is the answer of function here. To read this, as you can see here, this value from the truth table, the value is 0, but the output we get here is 1. So to read this value is 0, 1, 3 of 0, 1, 6 of 0, because static hazard happen, and 4 value of 1 to complete the cycle. So uh, the value is 0 here because glitch happened, and static hazard. F show how you solve the hazard and draw the logic gate implement with no hazard. So to answer this question, we need to reconstruct again the group adjacent, and as you can see here, we do a group adjacent one here to answer this question. So we get the form of W X Y bar Z. So from here we add X Y bar Z to into the logic diagram here. So this is the final form of logic diagram for hazard with no the logic gate with no hazard. That's all from me. Thank you.